Okay. All right. So for the quotient rule notes, we're going to try something a little bit different today. I've got my year 12 standard level math class here live. Kat wants to say hello. Hello.
Hi.
Yeah. Chris, anything beautiful to say? Huh? No, you're good. Alexa?
No, don't say.
Hi, go vegan.
Okay. That said, let's talk about the quotient rule. All right, so we're going to start by trying to find. I look really silly up here with the microphone, but that's okay. Let's try to find. I feel like I'm on a talk show. To find a derivative for the function y equals tan x. Do you guys, anybody know in here off the top of your head what the derivative of tan x is?
It's sin x.
Yeah, no, it's not. And we've got here. No, look at this is a graph of this one right here. This right here is tan x, right? And then this darker boldface graph is the graph of its derivative, right? You can see here on tan x, it's a really steep positive slope, then point of inflection, and then it continues to be positive. So its derivative is going to exist completely in the positive, in the top two quadrants, right? And here it goes from steep to less steep to less steep, and then more steep again, right? And it repeats. It's a periodic graph. Okay. Probably, can you even think of a function that looks like this?
X squared.
Yeah, it kind of looks like a parabola, but it's repetitive. It's periodic. So probably not even a good guess at what this function is going to be. Yeah. Now, if we rewrite tan x, remember that's the very definition of tangent, right? Tangent's opposite over adjacent, right? Sine over cosine. So we can rewrite tan x as sine x over cosine, right? Which is, what do we call this? What's the word for the result of dividing one thing by another? Look at the title. It's a quotient, right? So division, right? Division is a quotient, right? That's why we call this the quotient rule. So we'll need some sort of way to differentiate the result of dividing two functions. In other words, a quotient. Yeah, Megan's got a question. Megan.
So to find the derivative of tan, couldn't you just take the derivative of that equation and you get cosine over minus sine?
You might think so, but it doesn't quite work like that. Just like, if you remember, well, that's a great question, right? She says, why not just take the derivative of this and then the derivative of sine, the derivative of cosine, and then divide them? Well, if you think of the product rule, did we just take the derivative of the first function and the derivative of the second factor and then multiply them together? No, it's a little bit more complicated than that. And so in the same way, rather than just taking the derivative of sine and then the derivative of cosine and dividing them, we can't do that. It's going to take something a little more complex than that. Okay? All right, well, I'll show you. I'll present the quotient rule, and here it is. And if we're going to say if y is a function in terms of x, and it can be expressed as a quotient, right? The result of dividing. We'll talk about u and v, right? The same way that we did with the product rule, u times v. If we have u divided by v, here's what it looks like. dy dx, the derivative of y with respect to x, is equal to v. What's another word for v in the product? What do we call the top and the bottom part of a
Denominator.
Yeah, so u would be the numerator, and v would be the denominator. Exactly. Okay, so we've got v times, guys, we've got v times du dx. So v is the denominator times the derivative of the numerator. Very good. So the derivative of, or the bottom times the derivative of the top minus the numerator times the derivative of the denominator. Yeah. So this is about the same as, what does this remind you of? It looks like the product rule, except for instead of a plus we have a minus. Exactly. But we're not done. We have to divide the whole thing by the square of the denominator. Okay? So it's a little bit more computational intensive than the product rule, but it is still just a matter of taking derivatives of the two and then filling in the formula and simplifying. Okay? Or if we want to talk about it in function notation, right? This would be, if we call our quotient f of x divided by g of x, well then it's g times f dash minus f times g dash all over g squared. Yeah, that's it. And like we say, alternatively using words like we just discussed, the derivative of the quotient being the division, right? It's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. You guys got that? Great. Let's move on to an example. Okay. Example 1. We're going to go ahead and differentiate f of x equals tan x by using this quotient rule. Yeah? But first we're going to realize that tan x is equal to the quotient sine x over cosine x. Yeah? So let's use the Leibniz notation first. How can we? We should make some substitutions here, right? We're going to say, well, I guess they're using f of x. So let's call let's call f of x y, and so y is sine x over cosine x, right? So let's make some substitutions. Anyone have a suggestion?
H.
Sine x is u.
Very good. Yeah. Obviously, we're going to let sine x. Let's let u equal sine x, and let's let v equal cosine x, right? And therefore, our function, now our y equals u divided by v, right? And the quotient rule tells us that y dash is equal to v times v dx, no, du dx, sorry. Du, we'll put a little tail on it, right? Minus u times what?
The dv over
dv dx, yeah? All divided by
v squared.
v squared. Okay, so we should be able to do this. Let's just go ahead. I guess we should maybe write first, and we're going to have to squeeze this in here now, and that's okay. Or maybe I'll just write it above. If u is sine x, what is du dx?
Minus sine x.
Sorry?
Cosine.
Cosine x.
More.
Cosine x, right? And if v is cosine x, well, dv dx is what?
Sine x.
Sorry?
Minus sine.
Negative sine x. Okay? And now, all this quotient rule, now that we've done the differentiation, it's just a matter of substituting and then simplifying correctly. Yeah? So, our y dash, or I guess I should have, to keep the notation consistent, I should call this dy dx, and maybe I'll erase this and call this dy dx. Okay. Well, it's equal to v, which is cosine x, times the derivative of u, du dx, which we can see is
Cosine x.
also cosine x, times cosine x. Right? Here's cosine x, here's du dx, yeah? And then we're going to subtract u, which is,
I got that.
u is sine x, right? And then we're going to multiply by dv dx. What is dv dx? Minus sine x. Now, I know that you guys know this, but it bears repeating. Why, if I just write minus sine x, can I do that? No, what does this look like? This looks like minus sine x, but I see some people doing that sometimes when we're multiplying. What do I need to insert here?
Time.
Bracket.
I should put some brackets around. Anytime you're multiplying with negatives, you really need to put brackets around to make sure that you're indicating multiplication and not subtraction. Okay? And then we're going to divide this whole expression by the square of v. V in this case happens to be cosine x, and our notation for squaring trig functions is cosine squared of x. That's cosine x times cosine x. Now, if we simplify, what else should we notice? What does this here become?
Mr. Meyer?
Yeah.
Why don't we put the
Question, Kat.
Why don't we put the cosine x, the entire cosine x into the brackets? Why do you put the square only on the cosine?
Well, the reason is, her question is, why do we put this square here and not here? So, just to kind of write over here, why cosine squared of x and not cosine? What if we do it this way? What does this look like?
Cosine times x squared.
It looks like cosine. It's confusing whether this is cosine of x.
Can you put it in the whole thing?
It's confusing whether it's this or whether it is, or whether it's this. It's a little bit ambiguous. So if we put the square here, well, we know that we're taking the cosine of everything that follows and then squaring that result. Yeah? So it's just to avoid confusion.
Can't you put cosine x in a bracket and then put the whole bracket squared?
You can. That is the same thing. So we can say cosine squared x equals, just like you say, this is the same exact thing as that.
That's what I did.
Yeah. You can. Yep, you can do this, but we just don't want to. We don't like writing brackets all the time. Hi. Would you like to say anything?
Hello.
Yeah.
What is going? Sorry, I'm really sorry.
Don't worry.
Can I just grab my charger?
You can. Yeah. Of course you can.
Okay. I'm sorry, guys.
But you have to answer a question first.
I do.
What's the question, Mark? You get to
What is the derivative of tan?
What's the derivative of tan x?
Cos squared x.
Whoa.
Shoot.
No. Close though. Really close.
What is it?
We're about to find out. The suspense is killing you, I can tell.
I thought it was 1 +
I can't remember.
Okay. So if we notice here, guys, cosine x times cosine x, how can we express this? Anything times itself is the square, so we can express it just like we did in the bottom, right? Cosine squared of x. Are you not able to find your?
Maybe it's not here. I'm sorry.
No problem.
Is this yours?
No.
Okay, just find it.
Okay.
Thank you.
Yep. Okay, so let's rewrite this. Am I still red? Yeah, here we go. So dy dx simplifying is, we know that this is cosine, this becomes right here, this is cosine squared of x. So we have now cosine squared of x minus sine x times minus sine x is
plus sin x.
plus sine squared of x all over cosine squared of x.
So
Excellent.
we can cancel out.
No, we can't really cancel this top with the bottom because this is a sum here, right? We would have to find a common factor and pull it out before we could cancel, but we can't do that. One thing we can do, everybody have a glance at your formula booklet. Look in the trigonometry section. Do you recognize anything here? Anything familiar, maybe? Or what about you?
Can we just do separate it with cosine squared of x over cosine squared of x? Can we make sine squared of x over cosine squared of x? So that would make 1 plus 10, right?
No, because sine over cosine, yeah. Yeah, we could. I suppose we could. But I'm looking at the top here.
Yeah, it does. It really does equal 1 here. It's Pythagorean identity.
That's right, okay? This right here, and I'll just squeeze it in here. That green's kind of hard to see. Pythagorean identity. Right? Our Pythagorean identity is sine squared of x plus cosine squared of x equals 1. Yeah? Yeah, it comes from Pythagoras' theorem, right? Sine is opposite, cosine is adjacent. Those are the two legs of a right triangle. And we know that if we, a squared plus b squared equals c squared, on the unit circle, it's going to be the hypotenuse squared, which is 1. So it's going to be equal to 1. So this is equal to, we can make this Pythagorean identity replacement. Cosine squared plus sine squared equals 1. 1 over cosine squared of x. Okay? And that's our result. So we can summarize here. The derivative of the tangent function, right? It is tan x equals 1 over cosine squared of x. Okay? And this completes our derivatives of trig functions. Everybody knows now that the derivative of sine is
1 over cosine squared.
Sine is cosine. The derivative of cosine is negative sine, and the derivative of tan now is 1 over cosine squared. And you guys got it. Cool. Very good.
So, should it be tan dash x, not tan x?
Yes. Thank you. Okay. Yeah. So I guess what I can say is. That's what I should write. The derivative of tan x. Thank you. Okay. Yeah. Alright. Example 2.
Do you want to do this all in one video?
I don't know. Guys, this is gonna be one of those lessons where I'm gonna have to bounce downstairs back and forth because of some language exams to get them rolling. But I have your assignment, so you can get to work on that. But here's example 2. Let's see if we can squeeze this one in. Example 2. Given y equals 1 over 2x minus 3, find dy dx. But we're going to do this 2 ways. We're going to do it first by using the quotient rule like we just learned, and then we're going to try and verify our result using the chain rule. You might not see immediately how we'll use the chain rule, but we'll figure that out. We'll burn that bridge when we get there. Okay? So let's start with A. Okay? So y is 1 over 2x minus 3. Okay? Any suggestions on U and V? Jungmin?
No, I have a question.
H.
Jungmin has a question.
I have a question. What's that?
Oh, wait. No. Wait for the mic.
What's that sign next to street on person?
Those are the
That's a comma. English grammar. Given y equals 1 over 2x minus 3. Comma. Find dy dx.
This is going to be amazing video.
Yeah, it looks like derivative.
Good question, though.
That's a comma.
Okay. So let's talk about. Let's define our U and V. Alexa, what's U?
One.
Is your name Alexa, Nori?
Yes.
Okay.
One.
I'm gonna call you Lex from now on. All right. So U. Let's let U be 1. And so let's take the derivative right away. What's du
0.
dx?
0.
It's 0, right? Differentiating a constant number always gives us 0. And then let's call V. What should we call V?
2x minus 3.
2x minus 3. Easy enough. And therefore our dv dx equals 2. All right. And so now we know that our y dy dx is going to equal
0.
What does the quotient rule tell us? We start with what?
We multiply the denominator.
What's the first part? Yeah, the denominator, which is
Which is b.
v. So we're going to start with v. So we're going to do 2x minus 3. I'll probably put it in
Times
brackets.
0.
Times
Times the derivative of
the derivative of u times 0, which is 0, right?
Minus 2.
Oh, you
Minus-
you start with V.
Yeah, you start with v. Yeah.
Ah, that's different than the product rule. Then.
That's right. So it is a little bit backwards. That's right.
Okay.
And it's important with the product rule. Technically, we could write the product rule backwards because it's got a plus in between, and you know, addition's commutative. But subtraction, you gotta have the v first. It makes a difference. So start with the denominator. The denominator times the derivative of the numerator minus the
1 times
the numerator 1 times the derivative of the denominator, which is 2. Are we done?
No, divide by
All divided by
2x minus 3 squared.
2x minus 3 squared. Very good. Okay.
Should we expand the bracket?
Well, no, probably not. Not unless we need to for cancellation purposes or for, and yeah, probably not. So what do we get in the top? What does this leave us with?
Minus 2.
In the top we get this product becomes 0 minus 1 times 2. That's just going to be minus 2 divided by 2x minus 3 squared. Okay, no problem. All right, so that was using the quotient rule. What about the chain rule? How can we decide to differentiate this using the chain rule?
Same.
Remember, the chain rule.
Just say that 2x minus 3 is equal to u.
Right.
Yeah, and then just plug into u. So
Yeah,
it's
so
1
we
over
do
u dash times the derivative of 1 over u.
Yeah, what is the derivative of 1 over u?
Minus 1 over u squared. No,
No,
minus 2 over u
it's
squared.
it's minus u to the power of minus 2.
It reminds me of ln.
Yeah, minus
Okay.
1 over u squared.
Well, it's not natural log. That can be confusing because the derivative of natural
That
log
log
is 1
is
over x. Yeah, ln x is 1 over x, but not. Yeah, so but
Minus 1.
yeah, you're exactly right for it. But I'm going to suggest rewriting this first, right? Y equals 1 over 2 minus 2x minus 3. Can we rewrite this? When we use a chain rule,
Why?
can we rewrite it with an exponent,
Yeah,
perhaps?
in brackets 2x minus 3 to the power of minus 1.
That's right. This is the same thing as 2x minus 3
You
to
are
the negative 1.
surprised.
In Florida, this is exactly what you're suggesting. You just decided to leave it as a fraction, right? So now we can let u. What should we let our u be?
2x minus 3.
Yeah. Let u be the inside function, which is 2x minus 3. And now,
Oh my gosh, it's the same thing.
now y equals what? If u is 2x minus
to
3,
the power of minus 1.
this is u to the power of minus 1. Good.
Whoa, 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 whoa. Oh. Whoa, whoa.
So, if we recall, dy du becomes dy du. What's the derivative of u to the negative 1?
Minus u to the power of negative 2.
Yeah, minus u to the power of negative 2, which is
1 over u squared.
Negative.
negative 1 over u squared. Very good. And then what's du dx?
2.
Is just 2, right? So now, we know that the chain rule says it's the product of the derivatives of du dx, right? And dy du. So we're going to get dy dx is going to be, look, it's going to be 2 times negative 1 over, that's 2 times negative 1 over u squared, but what's our u? 2x minus 3. 2x minus 3 squared. And when I multiply the 2 into the numerator, of course we get minus 2 over 2x minus 3 squared. Yeah? And do we get the same thing?
What's the derivative of minus 1?
The product, or the quotient rule tells us this. The chain rule
Oh, really? You don't do like
agrees. Yeah?
Oh.
Very good. Okay, let's pause here.
Pause.
Stop recording.